So now we're going to have a look at these gases and see the properties of these. So first of all, we'll start with the gas hydrogen. Okay, so here is a balloon full of hydrogen, and of course we notice one of the properties of this gas, and that is it's much lighter than air. In fact, hydrogen is the lightest substance in the universe. Okay. This means we could use it to fill our balloons, our party balloons, or even airships, and here is the Hindenburg filled up with hydrogen gas. Now, actually, we don't fill our balloons with hydrogen, and this is for a very good reason. Despite it being the lightest substance in the universe, it's also rather flammable. And this is what happened to the Hindenburg. Okay? It crashed and burnt. So, well, let's see if we can try this with our balloon here. So this is a balloon filled with hydrogen gas. Apply a light, and it goes up. Okay, right. Notice our sugar is beginning to react quite vigorously there. Okay, there's actually a lot of heat being formed from this reaction, and that's creating steam, which is causing some of the bubbles and the carbon there that's forming to rise up. But anyway, so that's the sugars being dehydrated. Anyway, back to our gases. So we've seen then the reaction of hydrogen. This is hydrogen now recombining with the oxygen in the air, and this forms hydrogen oxide or water. But we don't see the water because actually it's instantly vaporized and spread out the room as water vapor. So we don't see that, but it's reforming the water, and it's also liberating a lot of energy. And no doubt you felt the energy there as the hydrogen and oxygen recombined. Well, here we have another balloon. This balloon is filled with pure oxygen gas. Now, of course, notice this time, this isn't floating up in the air. We've had to tie it to the retort stand here. And this is because oxygen is not lighter than air. It's about the same density. Not surprising, of course, because oxygen is one of the main components in the air. About 20% of the air is oxygen. Now, watch what happens when I apply a light to pure oxygen gas. Okay, are you ready? Not a lot. Okay, well, oxygen is not flammable. Oxygen doesn't burn. Oxygen allows things to burn, but itself doesn't burn. The hydrogen burnt very nicely because it was reacting with the oxygen that was in the air. The oxygen had nothing to do. Now, we've seen then that hydrogen can recombine with oxygen to form water. The question is, what ratio do we need to mix our hydrogen gas and our oxygen in to get the biggest bang, to get the best reaction? So this balloon here, the white balloon, is filled up with equal measures of hydrogen gas and oxygen gas. Okay? Now, see if this is any louder than the hydrogen itself. Now, the hydrogen balloon was bigger. It was a bigger balloon. But see if this one's louder. Let's listen. Okay, you ready? Yeah, I thought that was slightly louder. So that one was equal amounts of hydrogen and oxygen. Now this balloon contains twice as much oxygen. So this one has got 2 parts oxygen to 1 part hydrogen. Okay? Well, let's see if this one is any louder. Are we ready? No, not really. Wasn't quite the best mix. So what is the best ratio to mix these gases? We've had 1-to-1. That was pretty good, but I think we can do better. So what would the best ratio be? Any hands? Yep.
2 parts hydrogen, 1 part.
You're absolutely correct. 2 parts hydrogen to 1 part oxygen. And we know that this is right because the chemical formula for water is H2O. That means each molecule contains 2 atoms of hydrogen, 1 atom of oxygen. So that's the best ratio to mix them. Well, let's try this one then. This is 2 parts hydrogen, 1 part oxygen. And that was pretty loud.